Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/41 for the session October November 24. And we are going to solve the last of all questions, means question number 8. Let's read question number 8. A particle P moves in a straight line passing through a point O with velocity 4.2 meter per second. At time t second after P passes O, the acceleration a meter per second square of P is given by a equal to zero point 0.6 t minus 2.7. Find the distance P travels between the times at which it is at instantaneous rest. Well, this is a very interesting question, not difficult and twisted at all. It's very simple, which belongs to kinematics, and we are going to find distance. Look, so for finding distance from acceleration, first of all, we will move back to velocity. From acceleration, if we move back to velocity, we'll have to integrate acceleration. So integration of acceleration is velocity. First of all, let's find velocity. Okay, a is given, a equal to what? 0.60 minus 2.7. Well, first of all, we'll have to go back to velocity. For velocity, we'll have to integrate acceleration. If we integrate acceleration, a, so integration of acceleration a in terms of d, 0.6 integration mark t minus 2.7 integration mark 1, then it is in terms of dt. So if we if we integrate acceleration, it is nothing but velocity. So velocity is equal to, here power of t will be increased by 1, so it is going to be 2. If we divide 0.6 by 2, it is going to be 0.3. 0.3 t squared minus, if we integrate 1, integration of 1 is t, so 2.7 t, then plus the constant number. Well, then look at this. If we look at the question, we will see that particle P moves in a straight line passing through a point O with velocity 4.2. Look at this. When it was passing the origin, the velocity at the beginning, I mean t was 0 when the velocity was 4.2. So let us write t was 0, t equal to 0 when v is equal to 0. V is equal to not 0, V equal to 4.2 meter per second. After that, if we substitute the values we do have, what are the values we do have? 0.3 into 0 minus 2.7 into 0 plus constant value is equal to, right side is 4.2. If we simplify, left side is 0 except c, hence our c is equal to, c is going to be 4.2. Hence we can write the expression for our velocity. So v is equal to, what? V equal to, it is our expression 0.3 t squared, 0.3 t squared minus 2.7 t plus c is equal to 4.2. So this is the expression for velocity. That means this is a quadratic graph, and in this quadratic graph, initial value was 4.2. So if we draw a figure on the basis of this velocity expression, it is going to be, suppose this is time t second and velocity meter per second meter per second meter per second, and its origin P was passing through O. And if we look at the expression, what was the expression? Look at the expression, it is 0.3 t square minus 2.7 t plus 4.2. So constant number is 4.2. When t was 0, then velocity was 4.2. So let us write over here, suppose this is 4.2. 4.2 is over here, 4.2, and the curve is quadratic curve is positive, so it will look like something like this. Okay, and at this point, look at this, at this point and this point our velocity was 0. At this point the particle was at rest, and remember the area lying below the x-axis. Okay, we can discuss this part later on, but yet I am just shading this region which is lying below the x-axis. As it is lying below the x-axis, definitely this shaded region is negative. It will produce the negative, distance or displacement, whatever you tell. So what have we learned? At this point the particle was at 0. This is t1 and this is not t1. We don't need to write t1 t2. That is, these are the two time instant when the particle was at 0. Well, then let us see what we should do. This was the just curve, though this is not the part of your solution. They have told us to find the time. Look at this, speed travels between the times at which it was at instantaneous rest. So I have just shown it was at rest at this point as well as at this point. So we will find this point. At instantaneous rest, v was definitely 0, velocity was 0. So we can just write here, at rest, this is our expression for velocity. So at rest v is equal to 0. V equal to 0 means 0.3 t square, 0.3 t square minus 2.7 t plus 4.2 equals 0. If we multiply whole of the expression by 10, it is going to be 3t squared minus 27t plus not 20, yes, 27, it is going to be 42 is equal to 0. Or if we divide whole of the expression by 3, it is going to be t squared minus 3 9s are 27, 9t plus 3 14s are 42 equal to 0. Then if we break up the middle term, it is 9 square minus 7 2s are 14. So 7t minus 2t plus 14 equals 0. If we factorize this, we will get that t is equal to, in the first factor, t minus 7. The first factor is t minus 7 and second factor is t minus 2. Hence our time when velocity was 0 is equal to at 2 second as well as 7 second. Okay, from the graph we have already seen that the particle was at rest at this point. So the name of the time instant is 2. At the second the particle was at 0, and at 7th second also the particle was at 0. So here it is 7. It is going to be 7. So we have got the time when the particle was at instantaneous rest. And look at the question. They have told us to find find the distance p travels, the time at which it is at instantaneous rest. That means they have told us to find the area of this shaded region, because between the time 2 second and 7 second the particle was at rest, and between this time the distance it traveled is to be obtained. And look at this shaded region, or the distance shaded region is the actually area. We know how to find the area, and this shaded region or this displacement is lying below the x-axis, so surely it will produce a negative value. Well, from velocity we do have velocity. From velocity we are going to find the displacement. Okay, for displacement we know how can we find the displacement from velocity. It is very simple. If we integrate velocity we will get our displacement. Well, so we are going to integrate our v is equal to, this is our v. Okay, so displacement means integration of velocity. Well, so we will write v is equal to, what, 0.3 t square, 0.3 t square minus 2.70 2.70 plus 4.2 plus 4.2. And if we integrate this, we require, we don't need the whole integration, we will just integrate from second to 7th second, because this is the time when the particle was, these are the two moments when the particle was at rest. So we will find the displacement between 2 and 7 seconds. So the limit is, our limit is what? Yes, I think everything is visible here. Okay, our limit is 2 until 7 seconds. V dt is equal to 0.3 integration mark 2 until 7 seconds t squared minus 2.7 integration notation 2 until 7 seconds t plus 4.2 integration mark 2 until 7 seconds 4.2, and we can write the derivative in terms of dt. Okay, it is going to be dt. Well, let us integrate this definite integration. So if we integrate velocity we get s means displacement. Okay, and look at this here. In case of displacement, you know, the power increases by 1. If power increases by 1, it is going to be 3. So if you divide zero point 0.3 by 3, it is going to be 0.1, 0.1, then t cube, and the limit is 2 until 7 seconds, 2 until 7 seconds minus 2.7, then sorry, not 2.7, it is going to be 2.7 will be divided by 2, because the power of t is going to be now 2. So if we divide 2.7 by 2, it is going to be 1.35, 1.35, and if the power increases by 1, it is going to be t square, and limit is second from second until 7 second plus 4.2, and this is not 4.2, it is going to be 1 actually. Okay, this is 1, 4.2 and 1, it was 1, and integrand of 1 is always t. Okay, integrand of any constant number is t, so t, and limit is from 2 until 7 seconds. Now, the very important part of this solution, I have already shown frequently that look at this, the area we are going to find means the area of this portion, it is lying below the x-axis. Okay, as it is lying below the x-axis, it will produce a negative value. But our area can never be negative, so we'll have to convert it into positive. How can we do this? If we use modulus symbol, then it must be, we will pick up the positive value of this shaded region. Shaded region will produce, naturally it will produce negative value because it is lying below the x-axis. So remember, in such cases, if the area lies below the x-axis, it will produce negative value, and we should pick up the positive value. How can we find the positive value? Making it modulus, inside modulus. So this whole of this is inside the modulus symbol. Okay, modulus symbol. After that, or s equal to, well, t cube means 7 cube. 7 cube means zero point 0.1. So let us use the modulus symbol, and it is going to be 0.1 into, look at this, 7 cube means 343. 343 and 2 cube means 8. From 343, if we subtract 8, it is going to be 353. 335, sorry. 335. Okay, then minus 1.35, and 7 square. 7 square means 49, and 2 square means 4. 49 minus 4 means 5. 45. So 1.35 into 45 plus 7 and 2. 7 minus 2 is actually 5. So 4.2 into 5. 4.2 into 5. That's all, and our modulus symbol. Okay. Hence our displacement is going to be s is equal to mod of, if we multiply by 0.1, then it is going to be 33.5. So let us write 33.5. Modular symbol should be given using black ink. Okay, so it is going to be 33.5, 33.5 minus 1.35 into 45. Okay, 1.35 into 45, let it remain unchanged because we cannot do it mentally, it's very complicated. 45, and if we multiply 4.2 by 5, it is going to be 20 and 1, so 21. This is 21, and then modulus symbol. Okay, well, after that, if we simplify this, it is going to be, or is equal to, s equal to 33.5 plus 21. So it is going to be 54.5. 54.5 minus 1.35 into 45. Okay, then the modulus symbol here. Hence our s is equal to, our s is going to be what? Let me write with the same ink. Hence our displacement when the particle was at rest is 54.5 minus 1.35 into 44. Yes, then equal to 54.5 minus, let us calculate this. Yes, so it is 54.5 minus 2.5. So it is minus 6.25. Okay, that means our displacement can never be negative actually. So we will have to pick up the positive value, which is 6.25 meters, and which is our final answer. So I think you have understood this solution. It is not difficult at all, but please don't forget that from the graph we have seen that our displacement or the area or shaded region is lying below the x-axis. As it belongs to x-axis, so it must produce a negative value which should be converted to positive using modular symbol. Otherwise, it is very common and well known to us that first it's given acceleration. From acceleration, if you find velocity, there is nothing to be done except acceleration. Acceleration makes velocity acceleration integration makes acceleration into velocity, and to convert from velocity to displacement, again we do integration. So integration makes velocity into displacement, and finally our displacement is lying below the x-axis. That's why it produces negative value, and using modular symbol we can accept the positive value. That's all about this solution, and I think you have understood as much as I could explain. So thank you all for being with me. Fi amanillah.